We consider the equation dp dt equals kp, where capital P is not to be confused with the little p function we used in solving first order linear equations. Okay, the little p function was the coefficient of your y function. An example of this would be compound interest, where the rate at which your money grows, your principal, the rate at which your principal grows is a multiple of your principal. For example, your principal could grow at a rate 6%, meaning that you would get 6% of your principal. So your money would grow at a rate that's 6% of the amount you have. Now this would be compound interest, and there are some details to that we won't discuss right now. We'll see it later. But we want to solve this equation as a first order linear homogeneous equation, so we write it first in the form dp dt minus kp equals 0. And note that dp dt could be written as p prime. So we have p prime minus kp equals 0. That's much like y prime minus ky equals 0. Your little p of t function would be the k, the negative k. In any case, we solve this problem by first letting p equal e to the negative kt, so that p prime is negative k e to the negative kt. And our equation p prime minus kp equals 0 becomes p prime negative k e to the negative kt minus kp k e to the negative kt equals 0, and this is true. Now this is not the general solution. It's not our general solution because we don't have a constant in there, an arbitrary constant. K is not an arbitrary constant. K is a specific value that's dictated by this equation. So your general solution, as we've seen before, we can put any constant in front of this. So we could say P equals A e to the negative kt. You can verify that the a here doesn't make any difference. Our p prime will have a factor of a, our p will have a factor of a, which can then be divided out. So our general solution will be p equals a e to the negative kt. And now we try to apply this solution to the case where k is 0.06 and p is $1,000. This amounts to an investment of $1,000 at 6% interest, and with that interest compounded continually. What's our solution? Well, if k equals 0.06 and p equals $1,000, now I kind of misstated there. P equals $1,000 when t equals 0. So our initial p, and we'll call that p naught equal $1,000. This is going to correspond to a solution where k equals 0.06 and a equals what? Well, our general solution is p of t equals a e to the negative kt if p of 0, our principal at time t equals 0, is $1,000. Then, since p of 0 equals a e to the negative k times 0, which equals a, we have a equals $1,000, and our function becomes p of t equals $1,000 times e to the negative 0.06 t. And this will be our general solution to the equation. This is the function that tells you how much money you have if you continuously compound $1,000 at 6% and continue this for a time t.